Limits at infinity with radicals. You have to be very careful with limits involving radicals because there's a problem. The limit of 2x minus 1 divided by the square root of the quantity x squared minus 4 as x approaches negative infinity is equal to what value? By the given rules, we first check for the highest powers and they're the same because the square root of x squared is x. So we would have 2x over the square root of x squared. It reduces to 2. But the limit is actually negative 2, not 2. And let's see how. So if we graph our function in the coordinate plane and we approach negative infinity, we can see that it's clearly going to negative 2, not positive 2. So what happened? So let's revisit the trick from before where we divide every term by the highest powered term. So in this case, it's the square root of x squared, which is equal to the absolute value of x. And since x is approaching negative infinity, the value of x under consideration is negative in this case. So we can replace the absolute value of x by negative x, just like this. So first, divide each term by the absolute value of x. So divide both the numerator and denominator by the absolute value of x. And then that is equal to the limit of 2x minus 1 over negative x, because we're approaching negative infinity, all divided by square root of x squared minus 4, all divided by square root of x squared. Next, we can simplify each term. So we can divide 2x by negative x and get negative 2. And we can divide negative 1 over x to have positive 1 over x here. And then in the square root, we have x squared divided by x squared, which is 1 minus 4 divided by x squared. Every term in the form c over x, which is 1 over x and 4 over x squared, can be replaced by 0. Therefore, the limit of 2 plus 0 over the square root of 1 minus 0 as x approaches negative infinity is equal to negative 2. Find the indicated limit if it exists. The limit of 4x squared plus 5x minus 6, all divided by the square root of the quantity 9x to the 4th minus 5, and then outside of the radical plus x, as x approaches infinity. Start by dividing each term in the numerator or denominator by the square root of x to the 4th, which is equal to x squared. So since all of the terms in the numerator did not contain a radical, we divided all of them by x squared. And then the denominator, these first two terms were inside of the radical, so we're dividing it by the square root of x to the 4th. So then that way it does simplify to x squared, which is what we're dividing by on the outside of the radical. It is worth noting that because the resulting exponent, when you square root x to the 4th, that exponent for x squared is still even. So we do not need to be concerned about any absolute values when working with this function. In this next step, simplify wherever it's possible. So the x squareds in the first term cancel out. 5x divided by x squared is equal to 5 over x, and minus 6 over x squared stays the same. In the denominator, 9x to the 4th reduces to 9, minus 5 divided by x to the 4th, and then plus, on the outside of the radical, x divided by x squared reduces to 1 over x. In this last step, replace any terms in the form of c over x or c over x squared or c over x to the 4th with a 0 and then reduce. So we still have a 4 here, then 5 over x gets replaced by 0, minus 6 over x squared gets replaced with minus 0. We still have the square root of 9 minus 5 over x to the 4th becomes a 0, and then on the outside of the radical we have plus 1 over x becomes 0. And then we have positive 4 when we simplify the numerator, and we'll have positive 3 when we simplify the denominator. Some may be asking, why is it not plus or minus 3? Well, the reason why that's happening is because this radical symbol that's provided to us here does not contain a negative in front of it, so we automatically assume that the positive square root is being taken. So that is why the final answer here is 4/3. What happens in this scenario? The limit of the quantity square root of 2x squared minus 3x as x approaches infinity. If we use substitution, we're going to get an indeterminate outcome. We're going to get infinity minus infinity. But does infinity minus infinity equal 0? That answer kind of depends. Which term is getting bigger faster when we have the limit of f of x as x approaches infinity being equal to infinity minus infinity? For example, the limit of the quantity x cubed minus x squared as x approaches infinity is equal to infinity minus infinity, which is not equal to 0. Why does that happen? Well, no infinity value is actually the same, so infinity minus infinity cannot be concluded. Since there is no rational expression in this scenario, we cannot divide each term by the highest degree term. Instead, we're going to use conjugates to rewrite the expression as a fraction. And then we're going to solve it just as we do with infinity divided by infinity. So for example, if we're taking the limit of the square root of 2x squared, and then outside the radical we have minus 3x, and we're taking that limit as x approaches infinity, we're going to begin by multiplying by 1, and any expression over itself is equal to 1. So that expression is going to be this conjugate. So the square root of the quantity 2x squared inside the radical plus 3x outside of the radical over itself. The numerator, when we multiply, consists of a difference of squares. So we would end up getting 2x squared minus 9x squared. The middle terms would cancel out, so we don't necessarily have to write them. And then the denominator would be the square root of 2x squared, and then plus 3x would be outside of the root. And now if we take this rational expression, it simplifies to negative 7x squared because these top two terms are like terms. And now we can take the limit of negative 7x squared divided by the quantity square root of 2x squared, finish the radical, plus 3x. And now we can see that the degree of our numerator, which is 2 from the x squared, is greater than that of the denominator, meaning the square root of 2x squared would have a degree of 1 because the x squared would become absolute value of x. So its degree is 1. So since this top exponent is 2, which is bigger than 1, the limit of this function as x approaches infinity will be negative infinity because we have a negative 7 out in front of the x squared. We can verify this graphically too. So here's what the graph of the original function, square root of 2x squared, and then minus 3x outside the radical looks like. And showing the resulting function, it overlapped it directly. So therefore we clearly see that these two are the same, and then as x approaches positive infinity or continues to get bigger and bigger, the function values are getting smaller and smaller, so it's approaching negative infinity. Let's try another example that deals with radicals and conjugates. So we're going to evaluate the limit of the function that's the square root of x to the 8th plus 5, and then outside the square root minus x to the 4th. We're going to start by multiplying both the numerator and the denominator by the conjugate of our original function. And when we multiply the conjugate, we'll get the square root will go away. So it'll be x to the 8th plus 5, and then it'll be minus x to the 8th, because again, it's a difference of squares. The middle terms will cancel each other out. And then the denominator will be the square root of x to the 8th plus 5, ending the radical, and then plus x to the 4th. and we're going to take the limit of this as x approaches infinity. If we simplify the numerator, the x to the 8th minus x to the 8th cancel each other out, so we just have 5 remaining in the numerator, and then in the denominator we have the square root of x to the 8th plus 5, and then outside of the radical we have plus x to the 4th. Notice that the degree of the numerator is 0, and the degree of the denominator is 4. Therefore, the denominator degree is higher, so the limit equals 0. And if we verify this graphically, here's our original function in blue, and as x is approaching infinity, you can clearly see that the function is getting closer and closer and closer to 0. So this verifies it. And then if we look at our simplified version of it, it does directly overlap. So this means that both of these functions are equivalent to one another, so their limits will be the same.